Welcome to Ask and Learn.
So for this bungee jump problem, we need to draw a sketch situation. So we have a bungee jumper standing here with a rope attached to his feet. And then at this location here, he falls a distance of 15 meters. So we have a bungee jumper like this. And at this location, the cord begins to stretch. So till here, the cord just fully extends but not stretch. And then finally, he comes to the lowest point of his jump right here, and the cord stretches by a distance of, let's say, x2. Some distance it stretches. And the total height of his fall is h. So we neglect the air resistance. We have to estimate how far below the bridge Chris' foot would be before coming to a stop. So which means right at this location, this is his foot, and this is the water surface. So the zero location, well, first of all, only forces acting on the bungee jumper are gravity, and the elastic forces from the bungee cord. So jumper's mechanical energy is conserved. So at location 1, the jumper represents the bridge at this location, and the 2, at this position, he's at the bottom of the jump, the lowest point of his jump. So obviously at this point, V1 is equals to 0, and at this point also V2 is equals to 0. And this location here, y1 is equals to h, and at this location here, y2 is equals to 0. But the stretch is equals to h minus 15. So we equate the energies at these two locations. E1 equals E2. So total energy at E1, half mv1 squared plus mgy1 plus half k x1 squared. That should be equals to half mv2 squared plus mgy2 plus half kx2 squared. Now we know that v1 equals 0. So therefore this term will cancel. y1 equals 0, this term will cancel. On the left you simply have, sorry, this term is not equals to 0 here. So once again, v1 is equal to 0, therefore this term will cancel. There is no stretch in the string in location 1, therefore this term is cancelled. So therefore we have the total energy on the left hand side is simply mgh. On the right hand side, we have v2 is equal to 0, therefore this term is going to cancel. And y2 is equal to 0, this term is going to cancel, and the only energy on the right is the elastic potential, which is equal to half k x2, which is h minus 15 squared. Now in this, if you solve this equation, then you will get h squared minus 30 plus 2 mg by k, h plus 225 equals 0. And you can convert this to the quadratic equation, and substituting the mass in this, we'll get h squared minus 59.4 h plus 225 equals 0. So the mass is given 75 kilograms. Solving this quadratic equation, you will get h as equals to 60 meters. then you'll get two roots in this. We'll get the one root as 4 and another root as bigger than 4, but we should take um, the bigger value because the edge is greater than 15 meters, because 15 meters is the unstressed length of the string. So therefore, we cannot select the lower root in this answer. We have to select the higher root. So the answer is 60 meters.